Let's talk about derivatives, slopes of tangent lines, slope of secant lines, and instantaneous rates of change. Those are all essentially saying the same thing, and here's what it's saying. If I could take, if I could look at this function f of x, which is graphed there on the graph, and if I could break it down and analyze it and find a really good piece of information about it, it would be at any given point, like at the point x equals 2, what is at that instant, how fast is that graph changing? That's really what derivatives and slope and all these kind of things are. So this is what it's saying. If I could take a line, I'm going to try to draw a tangent line in here. That line right there, that's a bad one. That's just, no, that's close enough. Imagine it being moved over a little bit closer. But that would be like the slope, or that would be the tangent line, and the slope of that line, it looks like it's about maybe 5 or 6, right? Well, let's find out what it is. Here's how we find out what it is. We take the derivative of this, and I'm going to do it the shortcut way, and that's the derivative. You've maybe done it a couple different ways, but that's the derivative. Now, what is f prime of 1? At 1, what is the slope of that line? It's, oops, not at 1, at 2, sorry. I'm like, wait, that's not right. That's 0. What's the slope at 2 of that tangent line? What's the slope? What's 2 squared minus, what's 6 times 2 minus 6? It's 6. That line right there has a slope of 6. How about at the point, I'm going to change colors, how about at the point 3, which is going to be way up here, right? What's the slope of that tangent line? Well, now what's the tangent line look like? Do you think its slope's going to be bigger or smaller?
Yeah.
Is it steeper or less steep up there? Oh no, it's steeper.
Yeah. Okay.
What's the rate of change as you get further to the right of the point 1 of this vertex? What's the rate of change? I mean, what's the steepness? As I go further right, what's happening in a parabola? It's getting more and more what? Steep. That's a rate of change. Is the rate of change bigger on this green line or smaller on the green line than the red line?
Bigger.
It's bigger. It's steeper. How fast is it? And when I go over 1, I'm going to go up. Whoops. When I go over 1, I'm going to go up a whole bunch to get back to the line. What is it? Well, let's find out. What's f prime of 3? It's 3 times 6, which is 18, minus 6, which is what? 12. It's now 12. It's twice as steep. Got it? How about over here on the left? How about at the point right here? How about at the point 0, 0, 0? What's the slope of that tangent line? Hey, take a guess. What do you think it is?
-6.
Yeah, it's going to be -6. It's just going to be the negative of the red line. How fast is it at that point 0, 0? How fast is that graph f of x changing at that instant? Do you understand what I'm saying? What's the instantaneous rate of change? A rate of change is that lines have rates of change, and if I could narrow down every single point on this graph, that's the way I would narrow it down. I would turn it into, another way you say it is linearization. You're turning this graph into a bunch of lines. You're looking at this parabola as a bunch of lines. Those points, you take all the tangent lines, and those tangent lines carry a lot of information. Well, one piece of information, the instantaneous rate of change. That's what I'm trying to find. What's f prime of 0? Plug in 0. 6 times 0 minus 6 is -6. Hey, how about that? It's the negative of the other one. Why? Because it's going down. The line is going down. It's decreasing to the left. And so what is last one now? The big aha moment. How about at this point? How about at 1? What's f prime of 1? Well, look at it. What do you think the slope of that tangent line is going to be? What should it be? What kind of line is this right here?
Secant.
No, what kind of line is that I just drew in that purple line?
Horizontal.
It's a horizontal line. And what's the slope of a horizontal line?
0.
Slope of a horizontal line is 0. It better be 0. What happens when I plug in 1? I get what?
0.
And by the way, that right there is like one of the most important things in calculus too. Because if I have a cubic, let me do a particular problem now. I know I'm getting to calculus, but hopefully this helps you see the point of what you're doing. X cubed plus 3x squared minus 2x minus 1. That's some crazy graph, right? Wouldn't it be nice if I could find what points are really nice to know on this graph that I just drew?
The vertex.
How about those 2 points? Wouldn't those be awesome to know?
Yeah.
Well, guess what? We can find them now with calculus, because if I take the derivative, 3x squared plus 6x minus 2, that's the derivative.
How do you get the derivative?
You'd get it by using that long formula, or the trick is you take this right here, bring it down to the front and reduce it by 1. Bring this, multiply it down in the front, reduce it by 1. Bring this down to the front, multiply it and reduce it by 1, and that's gone. Don't tell anybody I taught you that, but that's the shortcut.
So you don't have to do that whole formula?
No, never again.
What the heck?
It's okay.
That's so dumb. Why
Don't
did they
tell
teach
the
you that?
teacher.
This video
Don't tell
Yeah.
the teacher I told you that, because that's
I
not what they want you to do right now. You need to learn your algebra. You got to be good with your algebra. But that right there, see that?
Okay, so
If
now
you
I
could
can check my answer.
If you could,
Okay.
right, if you could now find the zeros of that, and how could I find the zeros of that? You could either factor it or use the. Why am I finding the zeros of that? What do the zeros of this represent? It represents those 2 points. Make sense? So if you could only find those 2 zeros, you would know where those peaks and valleys are. Pretty sweet. And that's really the point, and I won't do that for you, but that's really the point. I think I've said too much.